0.15, and now this is still times 100,000. So, V out would be equal to minus 115,000 volts. That doesn't seem right. Probably aren't going to get negative 115,000 volts out of our little op amp. So there's a caveat to this, which is you're not going to get above your power supply or below your power supply. So if your power supply is hooked up to ground and plus 3.3 volts, when you get negative 115,000, the lowest you could go is the lowest your power supply goes, which is 0 volts. So you'd really get 0 volts here. But as the voltage goes up, and we're up here at 2.5 volts, now the sign changes, and this becomes a positive number. So this will be some positive number around approximately 1. So 1 times 100,000 is positive 100,000 something, but we can't get above 3.3 volts, so we get 3.3 volts out. So this would be logic 0 or 0 volts, or logic 1 and 3.3 volts. Okay, so that is a comparator is the very simplest analog to digital converter. It lets you compare an analog voltage to another analog voltage and answer this question: are we higher or lower? So if we could, instead of at this known input, if we could very quickly create a signal that did something like this. This might be a little confusing here, because I drew this like this. So in this example, I'm calling this flat line, I'm calling this our known voltage. And I'm calling this signal that's changing, I'm calling this one the unknown voltage. This is the one we're trying to find, and this is the one that we know what it is. Now, in this example, I'm reversing them. What I'm saying is, we have a known voltage, so this is our known voltage. And we have some unknown voltage that's moving at a slow rate. Okay, it's not steady, but it's changing. But it's changing very slow relative to how fast this is changing. This is changing very fast. And this is going to be our unknown voltage. And if we keep track of these steps, and we call this step 0, and this step 1, step 2, step 3, step 4, and so on. We'll just go to 15, a nice stopping point. Right? Then what we could do is we set our known voltage, and then we look at the output of our comparator. Are we low or high? And we do it again, right? And we continue up this stair step until we get to 11, and at the point when this voltage went above this voltage, the output of the comparator went from 0 volts to plus 3.3 volts. And we now have a much better approximation. Let's call this 3.3 volts here. A much better approximation of what this voltage is. So we said we had 16 levels. So we have 16 levels, and they went from 0 to 15. This should look very familiar, right? So we have 16 unique values, and the range is 0 to 15. And so if we divided 3.3 volts by 16 levels,